The Search for Extraterrestrial Life, Fact or Fiction. Written and published by Ciro Irmici. Feel free to subscribe for more content. Now let's get into the book. Introduction. Humanity's Endless Curiosity. For as long as humans have gazed up at the night sky, we've wondered, are we alone in the universe? From the earliest civilizations who crafted elaborate myths about gods and beings from the heavens, to modern scientists using powerful telescopes to probe the farthest reaches of space, the question of extraterrestrial life has never lost its allure. In fact, it may be one of the most profound and enduring questions of all time. In recent decades, the search for life beyond Earth has evolved from ancient speculation into a serious scientific endeavor. Organizations like NASA and private groups such as SETI, Search for Extraterrestrial Intelligence, have devoted immense resources to the mission. We've sent rovers to Mars, launched probes into the outer reaches of our solar system, and used sophisticated radio telescopes to listen for signals from distant stars. Yet, despite these efforts, no definitive evidence of alien life has been found. Or has it? Stories of UFO sightings and alien encounters have been around for centuries, with some convinced that extraterrestrial visitors have already made contact. But how much of this is grounded in reality, and how much is a product of human imagination or misinterpretation? Can life exist in the extreme environments we see on planets like Mars or the moons of Jupiter? If we do discover intelligent life, what would that mean for humanity? And perhaps more intriguingly, if the universe is so vast, why haven't we found anything yet? This book will take you on a journey through time and space, exploring humanity's fascination with extraterrestrial life. We will look at ancient beliefs, modern scientific breakthroughs, and the puzzling paradoxes that still leave us without answers. Along the way, we'll separate fact from fiction, examining the hard evidence and cutting-edge theories that fuel our curiosity. By the end of this journey, you may find yourself asking, is the search for extraterrestrial life a wild goose chase, or are we closer than ever to answering one of life's biggest mysteries? The truth could be out there, but are we ready to find it? Chapter 1. Ancient Beliefs and Modern Speculations. From the moment humans first gazed into the night sky, the idea that otherworldly beings might dwell among the stars took root in the human imagination. Across cultures, religions, and civilizations, tales of celestial beings and life beyond Earth have been passed down through generations. Some of these ancient stories echo strangely familiar themes, from heavenly messengers to mysterious creatures visiting from above, while modern science fiction builds on these same foundations, creating an intricate tapestry that blends fact with fantasy. Ancient civilizations and the sky gods. The earliest known records of extraterrestrial speculation date back thousands of years. Civilizations such as the Sumerians, Egyptians, Greeks, and Mayans not only studied the stars but often intertwined them with their mythology. In ancient Sumer, one of the earliest known cultures, texts like the Epic of Gilgamesh describe gods that came from the heavens to interact with humans, suggesting that the sky was a realm where gods and other beings resided. Some modern theorists speculate that these depictions of gods could, in fact, be early interpretations of extraterrestrial visitors. The ancient Egyptians believed that their gods traveled in celestial boats across the sky. Similarly, the Greeks spoke of deities like Zeus and Athena, who descended from Mount Olympus, a lofty, godly perch that some have likened to extraterrestrial origins. The Mayans, too, crafted vast calendars based on their observations of the stars and planets, weaving stories of creation that involved beings from beyond Earth. Even Hindu texts like the Mahabharata speak of flying chariots, known as vimanas, that roamed the skies, offering yet another glimpse into the ways ancient peoples conceptualized the possibility of life beyond our world. The Renaissance and the birth of modern speculation. As humanity evolved, so too did its understanding of the cosmos. During the Renaissance, thinkers like Copernicus and Galileo made groundbreaking observations about the universe, shifting human perspective from an Earth-centered model to a solar system where planets orbited the Sun. This monumental shift in thinking raised new questions. If Earth is not the center of the universe, could life exist elsewhere? In the 1600s, the Italian philosopher Giordano Bruno was one of the first to suggest that stars were suns surrounded by their own planets, which could potentially host life. This radical idea was ahead of its time, and Bruno paid a heavy price for his speculations. He was burned at the stake by the Inquisition. Yet, his ideas planted the seeds for future generations to contemplate the possibility of inhabited worlds beyond our own. By the 19th and early 20th centuries, the Industrial Revolution and the rise of scientific inquiry began to reshape the conversation. The works of science fiction pioneers such as Jules Verne and H.G. Wells began to capture the imaginations of the masses. Wells' iconic novel, The War of the Worlds, 1898, introduced the idea of hostile extraterrestrials invading Earth, igniting a cultural fascination with alien encounters. The science fiction genre flourished, sparking public interest in the possibility of life beyond Earth and how it might interact with humanity. Modern speculations and the rise of UFOs. By the mid-20th century, the conversation about extraterrestrial life took a dramatic turn. In 1947, a pilot named Kenneth Arnold reported seeing a series of flying saucers near Mount Rainier in Washington state, sparking the modern UFO phenomenon. Soon after, reports of strange objects in the sky and even alien abductions became widespread, leading many to believe that extraterrestrial visitors were already among us. One of the most famous cases, the alleged crash of an unidentified object in Roswell, New Mexico in 1947, fueled speculation that the U.S. government was hiding evidence of alien life. Despite official explanations attributing the event to a weather balloon, conspiracy theories continue to abound, and Roswell remains a focal point for those who believe in extraterrestrial visitations. In addition to these sightings, credible witnesses, including military pilots, astronauts, and scientists, have come forward with their own accounts of UFOs. In recent years, even the U.S. government has declassified certain reports of unidentified aerial phenomena (UAPs), acknowledging that there are objects in our skies that defy conventional explanation. While none of these reports offer definitive proof of alien life, they keep the door open to speculation, suggesting that something strange is occurring beyond our current understanding. Extraterrestrials in popular culture. While ancient myths laid the groundwork for the idea of life beyond Earth, modern pop culture has taken it to new heights. Science fiction films, books, and TV shows have crafted countless imaginative scenarios of what first contact with extraterrestrial life might look like. From Spielberg's Close Encounters of the Third Kind to Carl Sagan's Contact, these cultural artifacts reflect our hopes, fears, and endless curiosity about the unknown. Science fiction doesn't just entertain, it often mirrors our scientific advancements and philosophical questions. Shows like Star Trek explore not only the possibility of extraterrestrial life but also the ethical and societal implications of meeting it. Will extraterrestrials be peaceful explorers like the Vulcans of Star Trek, or warlike invaders as in Wells' War of the Worlds? Are they more advanced than us, or could they be primitive compared to human civilization? These stories resonate because they reflect our desire to understand our place in the cosmos. They allow us to project our own struggles, triumphs, and anxieties onto the idea of life beyond Earth. Bridging fact and fiction. As we move further into the 21st century, the line between fact and fiction in the search for extraterrestrial life continues to blur. On the one hand, scientists are closer than ever to discovering whether life exists on other planets or moons. Missions to Mars, the discovery of extremophiles, organisms that thrive in extreme environments on Earth, and the detection of exoplanets in habitable zones, all suggest that life beyond Earth is a possibility. On the other hand, our collective imagination, fueled by centuries of myth and modern entertainment, adds layers of speculation, wonder, and sometimes misinformation. In this chapter, we've taken a glimpse at how ancient beliefs laid the foundation for modern speculations about extraterrestrial life. As we journey further into the scientific realm in the next chapters, we'll explore the tools and methods humanity is using today to find out if we are truly alone in the universe. The question has endured through the ages, but now we may finally be on the verge of an answer. Chapter 2: The Science of Life Beyond Earth. As we venture deeper into the search for extraterrestrial life, we leave behind myths and folklore and step into the realm of science. The question, "Are we alone?" is no longer confined to ancient speculation or science fiction. It is now a legitimate scientific inquiry. But before we can understand the search for life beyond Earth, we must first define what we mean by life and examine the conditions necessary for its existence. What is life? A scientific definition. When scientists search for extraterrestrial life, they are often searching for something that might resemble life on Earth. But what exactly constitutes life? Biologists define life by a few basic characteristics: the ability to grow, reproduce, respond to stimuli, and undergo metabolism, the chemical processes that maintain living organisms. Life also needs to maintain homeostasis, which is the ability to regulate its internal environment to sustain these processes. On Earth, life is carbon-based, meaning all living organisms are composed of complex molecules that rely on carbon as their backbone. Water, too, is a critical element, acting as a solvent that allows for the chemical reactions necessary for life to occur. This combination of carbon chemistry and liquid water forms the foundation of what scientists call life as we know it. However, this leads to an important question. Is it possible that life beyond Earth could exist in a completely different form? Some scientists argue that extraterrestrial life may not need to rely on carbon or water. Instead, it could be based on entirely different chemical elements, such as silicon, or thrive in environments we would consider extreme or inhospitable. The Goldilocks zone, where life might thrive. A key factor in the search for life is the concept of the habitable zone, often referred to as the Goldilocks zone, around stars. This is the region in a solar system where conditions are just right for liquid water to exist. Planets that are too close to their stars will be too hot, causing water to evaporate, while those too far away will be too cold, causing water to freeze. In between, there's a narrow band where temperatures are suitable for liquid water, making these planets the most promising candidates for life. Earth, of course, resides within the Sun's habitable zone. Over the past few decades, astronomers have discovered thousands of exoplanets, planets orbiting stars outside our solar system, many of which fall within the habitable zones of their respective stars. Some of these exoplanets, like those in the TRAPPIST-1 system, have sparked excitement due to their potential to harbor liquid water, and by extension life. While the Goldilocks zone is a good starting point, scientists have realized that life might exist even in environments outside this perfect zone. Take, for example, the moons of Jupiter and Saturn, which lie far outside our solar system's habitable zone, yet show potential for hosting life. These moons, like Europa and Enceladus, have icy surfaces but may harbor vast oceans beneath, kept warm by gravitational forces that cause internal heating. Could life exist in these dark, frozen oceans? Scientists are determined to find out. Extremophiles, life in the harshest environments. On Earth, life is incredibly resilient. Organisms known as extremophiles thrive in environments that would be lethal to most other life forms. These remarkable creatures live in some of the harshest conditions imaginable. Inside deep-sea hydrothermal vents, in highly acidic lakes, in radioactive waste, and even in the frozen Antarctic ice. Their existence suggests that life, once it begins, can adapt to an astonishing range of environments. The study of extremophiles has revolutionized our understanding of the potential for life beyond Earth. If life can thrive in such extreme conditions on our planet, then perhaps it can also exist in equally extreme environments on other worlds. For example, Mars, with its freezing temperatures and thin atmosphere, was once thought too hostile to support life. But now, the discovery of extremophiles on Earth has led scientists to consider that microbial life might still be lurking beneath the Martian surface. Similarly, the moons Europa, Jupiter, and Enceladus, Saturn, have sparked interest due to the possibility of liquid water beneath their icy crusts. Missions like NASA's upcoming Europa Clipper will explore these moons in greater detail, searching for signs of life in their hidden oceans. If extremophiles can survive deep beneath Earth's oceans, why not in these alien environments? The search for biosignatures. So, how do scientists actually go about searching for life beyond Earth? One of the primary methods is to look for biosignatures, chemical or physical signs that indicate the presence of life. Biosignatures could include gases in a planet's atmosphere, such as oxygen or methane, which are often byproducts of biological processes. On Earth, for example, Oxygen in our atmosphere is produced by photosynthesizing plants and algae. If we detect large amounts of oxygen on an exoplanet, it could be a clue that life is present. In 2020, astronomers made headlines when they detected traces of phosphine gas in the atmosphere of Venus, a gas that, on Earth, is associated with microbial life. Venus, with its scorching surface temperatures and acidic atmosphere, was long thought to be inhospitable to life. However, the detection of phosphine raised the intriguing possibility that microbial life could exist in the upper layers of Venus's atmosphere, where conditions are more temperate. This discovery has led to renewed interest in Venus as a target for future exploration. NASA's James Webb Space Telescope, launched in 2021, is one of the most powerful tools ever built for studying distant planets and their atmospheres. It can detect the presence of biosignature gases and determine the composition of planets in other solar systems. As this technology improves, the chances of finding life increase significantly. Astrobiology, the study of life beyond Earth. The field of astrobiology is dedicated to understanding the potential for life beyond our planet. Astrobiologists combine disciplines like biology, chemistry, astronomy, and geology to study the conditions that support life and the potential for life to exist elsewhere. Their work often involves studying Earth's most extreme environments to learn about the limits of life and how it might arise on other worlds. One of the central questions in astrobiology is the origin of life itself. How did life begin on Earth? Was it a rare, one-time occurrence, or could the conditions that led to life be replicated elsewhere in the universe? Some scientists believe that life on Earth may have originated from space, delivered by comets or asteroids in a process known as panspermia. If true, this would mean that life, or at least the building blocks of life, might be far more common in the universe than we once thought. The Drake equation, calculating the odds of finding life. In 1961, astronomer Frank Drake developed an equation to estimate the number of intelligent civilizations in our galaxy. Known as the Drake equation, it factors in variables like the number of stars with planets, the fraction of planets that could support life, and the likelihood of intelligent life developing. While many of the variables in the Drake equation remain unknown, it remains a useful framework for thinking about the likelihood of extraterrestrial life. Based on the sheer number of stars in the universe, there are more stars in the observable universe than grains of sand on all the beaches of Earth. Many scientists believe that the odds of life existing elsewhere are quite high. Life as we don't know it. While most of the search for extraterrestrial life focuses on finding life similar to what we know on Earth, some scientists speculate that life could take forms we have yet to imagine. In this scenario, life might be based on different elements, such as silicon instead of carbon, or it might use liquid methane or ammonia instead of water. In fact, one of Saturn's moons, Titan, has lakes of liquid methane on its surface, raising the question, could life exist in a methane-based system? This concept, known as life as we don't know it, challenges our current understanding of biology and chemistry. While we are searching for life that mirrors Earth's life forms, the universe may be home to life in forms we can't even comprehend. As our exploration continues, we must keep an open mind about what life really means. Chapter 3: UFOs, Alien Abductions and Public Fascination. Few topics ignite the imagination and stir controversy quite like the notion of unidentified flying objects, UFOs, and alien encounters. For decades, UFO sightings and reports of extraterrestrial abductions have captured public attention, blending myth, mystery, and modern technology into a cultural phenomenon. Whether fueled by media, government secrecy, or collective wonder, the possibility of UFOs and aliens has become a central aspect of the debate surrounding extraterrestrial life. But how much of what we hear about UFOs and alien abductions is grounded in fact? Are these sightings merely optical illusions or misunderstood natural phenomena, or could they be evidence of visitors from other worlds? In this chapter, we explore the history, credibility, and intrigue of UFO sightings and alleged alien encounters, and how they've shaped public fascination. The birth of the UFO phenomenon, Kenneth Arnold and Roswell. The modern UFO phenomenon began in 1947, when pilot Kenneth Arnold reported seeing 9 saucer-like objects flying in formation near Mount Rainier, Washington. Arnold described the objects as moving at incredible speeds, faster than any known aircraft of the time. His sighting, widely publicized, is considered the first major UFO report in modern history and gave rise to the term flying saucer, despite Arnold later clarifying that the objects were crescent-shaped, not saucers. Just a few weeks later, in July 1947, another mysterious incident occurred in Roswell, New Mexico. A rancher discovered strange debris scattered across his property, leading to speculation that a UFO had crashed. The U.S. military initially released a statement confirming the recovery of a flying disc, only to later retract the claim, stating that the debris was from a weather balloon. This sudden reversal sparked widespread conspiracy theories, leading many to believe that the government was covering up evidence of extraterrestrial visitors. The Roswell incident remains one of the most famous UFO events in history, continuing to fuel speculation and debate. For decades, UFO enthusiasts have argued that the debris was part of a crashed alien spacecraft, while skeptics maintain it was merely a top-secret military project, part of an operation called Project Mogul, designed to monitor Soviet nuclear tests. Despite countless investigations, including an official government report in the 1990s, the Roswell story remains a cornerstone of UFO lore. Government secrecy in UFOs, the role of the military. One of the key elements that keeps the UFO phenomenon alive is the role of government secrecy. Over the years, various governments, most notably the U.S., have been accused of hiding evidence of UFOs and extraterrestrial contact. This secrecy has only deepened public fascination, with many believing that the truth is being deliberately suppressed. Programs like Project Blue Book, a U.S. Air Force investigation into UFO sightings that ran from 1952 to 1969, were meant to analyze UFO reports and determine whether they posed any national security threat. While the vast majority of cases were explained as natural phenomena or misidentified aircraft, a small percentage remained unidentified, leading to speculation that the government was not telling the full story. In recent years, the U.S. government has declassified several reports on unidentified aerial phenomena, UAPs, the modern term for UFOs. In 2020, the Pentagon confirmed the authenticity of several videos showing strange, fast-moving objects that were recorded by Navy pilots. The footage, which had been leaked to the public, showed objects displaying flight characteristics that defied the capabilities of known aircraft. These revelations have reignited public interest in UFOs and raised new questions about what, exactly, these objects could be. While the government has acknowledged the existence of UAPs, it has stopped short of suggesting extraterrestrial involvement. Instead, officials emphasize that these objects could represent advanced technology from foreign adversaries or unknown natural phenomena. Still, the fact that such sightings continue to defy explanation keeps the door open to speculation, and further deepens the mystery. Alien abductions, fact or fantasy? Perhaps even more captivating and controversial than UFO sightings are the numerous accounts of alien abductions. Beginning in the mid-20th century, people around the world began reporting strange experiences in which they claimed to have been taken aboard alien spacecraft, subjected to medical experiments, and then returned to Earth with little or no memory of the event. One of the first and most famous alien abduction stories came from Betty and Barney Hill, a couple from New Hampshire in 1961. The Hills reported seeing a UFO while driving home one night, after which they experienced 2 hours of missing time. Under hypnosis, both Betty and Barney recalled being abducted by humanoid beings who conducted medical examinations on them aboard a spacecraft. Their case became a sensation, and their descriptions of the aliens, small gray beings with large heads and eyes, became iconic, shaping the popular image of extraterrestrials that endures to this day. Over the years, thousands of people have come forward with similar stories. The phenomenon of missing time, where abductees lose consciousness or memory of the event, is a common theme, as are descriptions of medical procedures, telepathic communication, and feelings of paralysis. While some abduction accounts have been thoroughly investigated and deemed hoaxes or delusions, others remain unexplained, leaving some psychologists and researchers wondering if the phenomenon might have a deeper psychological or even physiological basis. Many skeptics argue that alien abduction stories can be explained by sleep paralysis, a condition in which individuals, often upon waking or falling asleep, find themselves unable to move and experience vivid hallucinations. Sleep paralysis, combined with the cultural influence of UFOs and aliens in media, may account for many abduction reports. Still, the sheer number of accounts, along with their consistency across time and geography, has led some to believe that there may be more to the phenomenon than simple psychological explanations. Public fascination and media influence. The cultural fascination with UFOs and alien abductions has been fueled by media, from the earliest radio broadcasts to today's blockbuster movies. In 1938, Orson Welles famously broadcast a radio adaptation of H.G. Wells' The War of the Worlds, depicting an alien invasion of Earth. The broadcast was so realistic that it reportedly caused panic among listeners, many of whom believed that the invasion was real. This event showed just how deeply the idea of extraterrestrial life had permeated public consciousness. Since then, UFOs and aliens have become staples of popular culture. Movies like Close Encounters of the Third Kind, 1977, E.T. 1982, and Independence Day, 1996, have captivated audiences and shaped our collective imagination about what contact with extraterrestrial life might look like. Television shows like The X-Files further embedded the idea that the truth is out there, playing into themes of government conspiracy, secret alien agendas, and the possibility of ongoing extraterrestrial contact. The media's portrayal of UFOs and alien abductions has undoubtedly influenced public perception, creating a feedback loop where fiction and reality blur. As more people consume stories about extraterrestrials, their expectations and imaginations are shaped by what they've seen and read. This, in turn, influences how people interpret strange experiences, leading to more UFO sightings and abduction claims. The skeptics, explanations and debunking. While UFO enthusiasts and alien abduction claimants have built a robust subculture around the belief in extraterrestrial contact, skeptics have consistently challenged these claims. Most UFO sightings can be attributed to natural phenomena, such as atmospheric conditions, weather balloons, or even optical illusions. Additionally, many alleged UFO photos and videos have been debunked as hoaxes or misidentified conventional aircraft. As for alien abduction reports, psychologists point to the human brain's susceptibility to suggestion and the power of cultural influence in shaping memories. The phenomenon of false memories, where people come to believe they have experienced events that never occurred, has been well documented, and many abduction accounts may fit into this category. Nevertheless, there remain UFO sightings and abduction stories that defy easy explanation. For some, the unknown variables leave room for belief in extraterrestrial involvement, while for others, the lack of conclusive evidence is reason enough to remain skeptical. Whether these events are rooted in reality or imagination, they continue to captivate people worldwide. UFOs and the future, moving toward the truth. As we move deeper into the 21st century, the conversation around UFOs and extraterrestrial life has shifted from the fringes to the mainstream. With the U.S. government now openly discussing UAPs and releasing previously classified information, the stigma around UFO research is beginning to fade. Scientists, military personnel, and politicians are calling for more transparent investigations into these phenomena, signaling a new era in the search for answers. In the coming years, advances in technology, such as more powerful telescopes, artificial intelligence for pattern recognition, and increased access to space through private ventures, could help shed light on the UFO mystery. Whether these sightings are ultimately explained as foreign drones, new natural phenomena, or something more otherworldly, one thing is clear: the search for truth continues. Chapter 4. SETI and the Search for Signals. If there is intelligent life beyond Earth, how might we find it? For decades, scientists have considered one intriguing possibility. Perhaps advanced civilizations are transmitting signals across the galaxy, trying to communicate just as we might do. This is where the search for extraterrestrial intelligence, SETI, comes into play. Founded on the principle that if intelligent alien life exists, it could be detected through its radio or other electromagnetic signals, SETI has become one of the most well-known scientific efforts to answer the age-old question, are we alone? In this chapter we'll dive into the history of SETI, the technologies it employs, and what we've learned so far in our quest to hear from the stars. The birth of SETI, a scientific endeavor. The origins of SETI can be traced back to 1960, when astronomer Frank Drake, inspired by the potential for advanced civilizations elsewhere in the universe, conducted the first experiment aimed at detecting alien signals. Known as Project Ozma, Drake used a radio telescope to scan two nearby stars, Tau Ceti and Epsilon Eridani, for radio transmissions. While the project did not detect any extraterrestrial signals, it marked the beginning of a new scientific field dedicated to searching for intelligent life beyond Earth. Drake's work also led to the formulation of the now famous Drake equation, an attempt to estimate the number of advanced civilizations in our galaxy. The equation considers factors such as the number of stars with planets, the fraction of planets that could support life, the likelihood of intelligent life developing, and the longevity of civilizations capable of communication. Though many of the variables in the equation are still unknown, it has provided a valuable framework for thinking about the odds of finding extraterrestrial intelligence. Since the early days of Project Ozma, SETI has expanded into a global effort, involving numerous observatories, private institutions, and governments around the world. SETI researchers use sophisticated radio telescopes to scan the sky for signals that could originate from intelligent sources, and advances in technology have made it possible to search broader regions of the sky and wider bands of the radio spectrum than ever before. How SETI works: listening to the universe. SETI's primary method of detecting alien civilizations is by searching for narrowband radio signals, signals concentrated in a small part of the radio spectrum. Unlike natural phenomena such as stars or planets, which emit signals across a wide range of frequencies, narrowband signals are often associated with artificial transmissions, such as those generated by human technology. The logic behind this search is simple. If an advanced civilization wanted to communicate with others across the galaxy, it would likely use radio waves. Radio waves travel at the speed of light and can traverse the vast distances of space without being absorbed by interstellar dust or gas, making them an ideal medium for long-distance communication. Additionally, radio waves are relatively easy to generate and detect, so it's possible that other civilizations, if they exist, might also use this technology. SETI scientists use massive radio telescopes to listen for these signals. The telescopes scan different parts of the sky, targeting regions where stars are known to have exoplanets, particularly those in the habitable zone, where conditions could support life. Computers analyze the data collected by the telescopes, looking for patterns or signals that stand out from the background noise of space. The challenge, however, is that space is filled with a wide variety of natural radio emissions, from pulsars, quasars, and other cosmic phenomena, that can easily be mistaken for artificial signals. In recent years, SETI has expanded its search beyond just radio waves. With the development of new technologies, scientists are now exploring other forms of electromagnetic radiation, such as optical signals, visible light, and laser pulses, which could also be used for interstellar communication. The hope is that by broadening the scope of the search, we might increase our chances of finding something. SETI successes and false alarms. While SETI has yet to detect a confirmed signal from an extraterrestrial civilization, there have been several intriguing events over the years that sparked excitement, only to later be explained as natural or human-made phenomena. One of the most famous cases occurred in 1977 when a radio telescope at Ohio State University detected an unusual signal that became known as the WOW signal. The signal, a strong and narrow-band burst of radio waves, lasted for 72 seconds and appeared to come from a region of space where no known human-made transmissions were present. Astronomer Jerry Emin, who discovered the signal, was so astonished by it that he wrote "Wow" in the margin of the data sheet, giving the signal its now legendary name. Despite extensive follow-up observations, the WOW signal has never been detected again, leaving its origin a mystery. Some researchers believe it may have been a signal from an extraterrestrial source, while others argue that it could have been caused by a natural phenomenon or a terrestrial interference that was never identified. Other instances of potential signals have also turned out to be false alarms. In 1997, for example, a SETI team detected a series of signals that, for several days, seemed to originate from deep space. However, it was later revealed that the signals were caused by a malfunctioning microwave oven in the observatory's break room. A humorous but humbling reminder of the challenges SETI researchers face in distinguishing between artificial and natural sources of radio waves. Despite these false alarms, SETI scientists remain optimistic. The universe is vast, and the search for extraterrestrial intelligence is still in its early stages. As technology improves, the hope is that we will one day stumble upon a genuine signal, one that could change our understanding of the universe forever. The challenges of SETI: vast distances and time scales. One of the greatest challenges facing SETI is the immense scale of the universe. The Milky Way galaxy alone contains an estimated 100 to 400 billion stars, many of which could have planets orbiting them. Searching the entire galaxy for signals is like trying to find a needle in an interstellar haystack. Another challenge is the time scale involved in interstellar communication. Radio waves travel at the speed of light, which means that even a signal from the nearest star system, Proxima Centauri, would take over 4 years to reach Earth. If an advanced civilization in a more distant part of the galaxy were to send a signal, it could take tens, hundreds, or even thousands of years to arrive. Additionally, any civilization capable of sending signals would need to be transmitting at the right time for us to detect them. Given the age of the universe, over 13 billion years, it's possible that other civilizations may have risen and fallen long before humans developed the technology to listen. If so, their signals could be reaching us now long after their civilizations have disappeared. Another consideration is the water hole, a specific range of frequencies between 1420 and 1720 MHz. This range is relatively free of background noise, and it includes the natural emissions of hydrogen and hydroxyl, which are abundant in space. Some scientists believe that if extraterrestrials were trying to communicate, they might use this frequency range, as it would be a logical choice for interstellar communication. SETI focuses much of its attention on this range, though there is no guarantee that alien civilizations would think the same way. The role of private organizations in the future of SETI. In recent years, the search for extraterrestrial intelligence has received support from private organizations and philanthropists, most notably Russian billionaire Yuri Milner's Breakthrough Listen initiative. Launched in 2015, Breakthrough Listen is the most comprehensive SETI effort to date, with a budget of $100 million. It funds observations at some of the world's largest radio telescopes and uses cutting-edge technology to analyze data for potential signals. This private funding has revitalized the search for extraterrestrial life at a time when government support for SETI has dwindled. In the early 1990s, NASA briefly funded a SETI project, but it was canceled after just a year due to budget cuts and political pressure. Since then, much of SETI's work has relied on private donations and collaborations with universities and research institutions. As technology advances, the future of SETI looks promising. The development of more powerful telescopes, artificial intelligence for analyzing massive amounts of data, and the growing catalog of exoplanets in habitable zones all increase the likelihood that we might one day detect a signal from an intelligent civilization. However, the search is not without its critics. Some argue that the focus on radio signals is too narrow and that intelligent civilizations might communicate in ways we cannot yet imagine. Others question whether we should be actively searching at all, raising concerns about the potential dangers of alerting hostile extraterrestrials to our presence. Despite these concerns, SETI remains a beacon of hope for those who believe that intelligent life exists beyond Earth. Whether we find it tomorrow, in 100 years, or never at all, the search itself reflects humanity's deepest desire to understand our place in the cosmos. Chapter 5: Exoplanets and Habitable Zones. One of the most significant scientific breakthroughs in the search for extraterrestrial life came in the last few decades with the discovery of exoplanets, planets that orbit stars outside our solar system. These distant worlds have ignited excitement among astronomers and astrobiologists, as they offer potential new homes for life. But among the billions of stars in our galaxy, how do we know which exoplanets might be capable of supporting life? In this chapter we'll explore the discovery of exoplanets, the concept of habitable zones, and the methods scientists use to determine whether these distant worlds could harbor life. The discovery of exoplanets, a new frontier. Until the 1990s, the idea of planets existing outside our solar system was mostly theoretical. While scientists had long suspected that other stars might host planets, the technology to detect them simply didn't exist. That all changed in 1992 when astronomers made the first confirmed discovery of exoplanets orbiting a pulsar, a type of neutron star, called PSR B1257+12. Although these planets were unlikely candidates for hosting life due to the extreme radiation from their star, their discovery marked a pivotal moment in astronomy. Just a few years later, in 1995, a team of Swiss astronomers discovered 51 Pegasi b, the first exoplanet found orbiting a Sun-like star. This gas giant, similar to Jupiter, was a hot Jupiter, orbiting much closer to its star than any planet in our solar system orbits the Sun. While it wasn't a likely home for life, 51 Pegasi b opened the floodgates for further exoplanet discoveries. Since then, advances in technology, particularly with space-based telescopes like Kepler and TESS, Transiting Exoplanet Survey Satellite, have allowed astronomers to discover thousands of exoplanets in various star systems across the galaxy. Some of these planets are gas giants like Jupiter and Saturn, while others are rocky, Earth-like worlds which hold the greatest potential for life. The habitable zone, where life might thrive. When searching for life beyond Earth, scientists focus on planets that reside in what is known as the habitable zone. Also referred to as the Goldilocks zone, this is the region around a star where conditions are just right for liquid water to exist on a planet's surface. Water is essential for life as we know it, and planets in the habitable zone are the most likely candidates for supporting life. The concept of the habitable zone varies depending on the type of star a planet orbits. For example, planets orbiting smaller, cooler stars like red dwarfs would have habitable zones much closer to the star, while those orbiting larger, hotter stars would need to be farther away to maintain temperatures suitable for liquid water. Earth, naturally, is the prime example of a planet in the habitable zone. It lies at just the right distance from the Sun, allowing for stable liquid water and a relatively mild climate, key ingredients for the development and sustainability of life. By identifying exoplanets in similar conditions, astronomers hope to find other Earth-like worlds where life could potentially exist. However, the habitable zone is just one factor in determining whether a planet can support life. A planet also needs to have a stable atmosphere, the right chemical composition, and other features that make it hospitable. Additionally, while liquid water is necessary for life as we know it, some scientists believe that other forms of life could thrive in environments without water or in entirely different chemical ecosystems, which expands the possibilities for what we should be looking for. Methods of detecting exoplanets. The discovery of exoplanets has been made possible by a few key techniques, each of which allows astronomers to observe planets indirectly, since directly imaging distant exoplanets is extremely difficult due to their faintness and proximity to their host stars. 1. Transit method. The most successful and widely used method for detecting exoplanets is the transit method, employed by telescopes like Kepler. This technique involves monitoring the light from a star and looking for periodic dimming. If a planet passes in front of the star from our line of sight, it temporarily blocks a small portion of the star's light, causing the star to dip in brightness. By analyzing the timing and extent of these dips, scientists can infer the presence of an exoplanet, estimate its size, and determine its orbital period. This method has been particularly effective for identifying planets in the habitable zones of their stars. 2. Radial velocity Doppler method. Another method for detecting exoplanets is by measuring the radial velocity of a star, which refers to the slight wobble caused by the gravitational pull of an orbiting planet. As the planet tugs on its host star, the star moves toward and away from us, shifting the light it emits. This shift, known as the Doppler effect, can be detected by observing the star's spectrum. By measuring these shifts, scientists can calculate the planet's mass and orbit. This method has been crucial in discovering gas giants and larger exoplanets. 3. Direct imaging. Though challenging, direct imaging of exoplanets is sometimes possible, particularly when looking at young planets that are still glowing with heat or when advanced techniques, such as coronagraphs, are used to block out the star's light. Direct imaging allows scientists to observe the planet itself and study its atmosphere and surface characteristics, though this method is far less common due to technological limitations. 4. Gravitational microlensing. This technique involves observing the bending of light caused by a planet passing in front of a distant background star. The gravity of the planet acts like a lens, magnifying the light from the background star. While rare, this method can reveal planets at great distances from Earth, even in regions of space where other detection methods struggle to reach. These methods, combined with the ever-improving technology of space telescopes and ground-based observatories, continue to expand our catalog of known exoplanets, bringing us closer to finding planets that might support life. Earth-like exoplanets. The search for another Earth. Among the thousands of exoplanets discovered, some have emerged as particularly exciting candidates for habitability. These Earth-like exoplanets, known as super-Earths, are rocky planets with a mass larger than Earth but smaller than gas giants like Neptune. Super-Earths are of great interest to scientists because their size and composition suggest they could have conditions similar to Earth's, making them potential homes for life. One of the most famous discoveries is the TRAPPIST-1 system, located about 39 light-years from Earth. This system contains 7 Earth-sized planets, 3 of which lie within the star's habitable zone. These planets, orbiting a cool red dwarf star, have captured the attention of astronomers due to their potential for liquid water and stable climates. While much more study is needed to determine their exact conditions, the TRAPPIST-1 system is a promising target for future exploration. Another intriguing candidate is Proxima Centauri b, an Earth-sized exoplanet orbiting the star Proxima Centauri, the closest star to the Sun, located just 4.2 light-years away. Proxima b lies within its star's habitable zone and could potentially have liquid water. Its proximity to Earth makes it a prime target for future missions, and if conditions are favorable, it could be one of the best opportunities to discover life outside our solar system. In addition to these, other exoplanets like Kepler-452b and LHS-1140b have also raised hopes of finding habitable worlds. Kepler-452b, sometimes called Earth's cousin, is located in its star's habitable zone, while LHS-1140b is a super-Earth orbiting a nearby red dwarf. Challenges in determining habitability. While the discovery of exoplanets in habitable zones is a major step forward, determining whether these planets are truly habitable is a much more complicated task. For life to thrive, a planet must have more than just liquid water. It needs a stable climate, a protective atmosphere, and the right chemical ingredients. One of the biggest challenges is atmospheric composition. A planet's atmosphere plays a critical role in regulating temperature, protecting against harmful radiation, and enabling the chemical reactions necessary for life. For example, Earth's atmosphere, rich in oxygen and nitrogen, is essential for maintaining the conditions needed for life. When searching for exoplanets, scientists look for signs of certain gases, such as oxygen, methane, and carbon dioxide, which could indicate the presence of life or the potential for life-sustaining environments. Another challenge is a planet's magnetic field. Earth's magnetic field protects us from the sun's harmful solar winds, preventing our atmosphere from being stripped away. Without a magnetic field, a planet's atmosphere could be eroded over time, making it difficult for life to survive. Determining whether exoplanets have magnetic fields is a complex and ongoing area of research. Finally, scientists must consider the long-term stability of a planet's environment. A planet may lie within the habitable zone of its star, but if the star itself is unstable, prone to flaring or significant changes in brightness, it could make life on the planet difficult or impossible. What's next? Future missions and the search for life. As our understanding of exoplanets grows, so too does our ability to explore them in greater detail. The launch of new space telescopes like the James Webb Space Telescope (JWST) promises to revolutionize our study of exoplanet atmospheres. The JWST will be able to analyze the light passing through exoplanet atmospheres to detect the presence of key gases like oxygen and methane, giving scientists an unprecedented glimpse into the potential habitability of distant worlds. Other upcoming missions like LUVOIR Large Ultraviolet Optical Infrared Surveyor and HABEX Habitable Exoplanet Observatory will further enhance our ability to detect and study Earth-like exoplanets. These missions aim to directly image exoplanets, allowing scientists to study their atmospheres, climates, and potential biosignatures in much greater detail than ever before. While we have yet to find definitive proof of life on any exoplanet, the search is only just beginning. With each new discovery, we move closer to answering one of humanity's most profound questions. Are we alone in the universe, or is life thriving in the distant reaches of space? Chapter 6. Mars, our neighbor and potential host for life. Of all the planets in our solar system, none has captured humanity's imagination quite like Mars. Often called the red planet due to its rusty surface, Mars has long been considered a prime candidate for harboring life. Its proximity to Earth, its historical allure in science fiction, and the tantalizing hints of water beneath its surface have made Mars the focal point of numerous space missions. But is Mars truly capable of hosting life, either now or in the distant past? In this chapter we'll explore Mars' history, its unique characteristics, and what we've learned from decades of exploration. Mars in myth and science fiction. An early fascination. Mars has fascinated humans for centuries. To ancient civilizations, its reddish hue made it stand out from the other visible planets, and many associated it with war and aggression, naming it after their gods of war, Ares in Greek mythology and Mars in Roman. Its enigmatic nature made it a frequent subject in early astronomy, and its motion across the night sky gave rise to early ideas about its nature. In the late 19th century, astronomer Percival Lowell popularized the idea that Mars could host intelligent life. Using a telescope, Lowell claimed to have seen a network of canals on the Martian surface, which he believed were built by a highly advanced civilization to transport water. Although these observations were later debunked, what Lowell saw was an optical illusion. His theories fueled public imagination, giving rise to an entire genre of science fiction centered around Mars. H.G. Wells' The War of the Worlds, first published in 1898, cemented Mars' place in popular culture. The novel depicted a Martian invasion of Earth, introducing the idea that intelligent beings from Mars might be watching us. Since then, Mars has been the setting for countless books, movies, and TV shows, from Ray Bradbury's The Martian Chronicles to the 2015 film The Martian. But as our technology has improved, Mars has transitioned from the realm of fiction to one of scientific inquiry. Why Mars? The quest for habitability. Mars has long intrigued scientists because, in many ways, it is the planet in our solar system most similar to Earth. Although smaller, Mars has seasons, polar ice caps, and a day that is just a little longer than ours, 24.6 hours. Additionally, it has evidence of ancient riverbeds, lake basins, and minerals that only form in the presence of water, suggesting that it once had a much wetter and possibly warmer climate. Mars' history holds clues that it may have been more Earth-like billions of years ago. Early in its history, Mars likely had a thicker atmosphere and liquid water on its surface, two key ingredients for life as we know it. This has led scientists to speculate that Mars might have supported microbial life in the distant past. However, over time the planet's atmosphere thinned, and its surface water disappeared, leaving behind a cold, dry desert. Today the surface of Mars is incredibly inhospitable. The planet's atmosphere is 100 times thinner than Earth's and composed mostly of carbon dioxide, offering little protection from harmful solar radiation. Temperatures on Mars can drop to -80 degrees Fahrenheit, -62 degrees Celsius, at night, and dust storms can engulf the planet for weeks. Despite these challenges, scientists believe that Mars may still hold some surprises. The water question, ancient rivers and hidden ice. One of the most important questions in the search for life on Mars is whether liquid water, essential for life on Earth, still exists there today. While Mars is too cold for liquid water to exist on the surface for long, evidence suggests that water was once abundant on the planet. Pictures from rovers and orbiters have shown ancient river valleys, deltas and lake beds, all of which indicate that water once flowed freely on the Martian surface. In 2004, NASA's Opportunity rover discovered clear signs that water had once existed on Mars in the form of sulfate minerals, which only form in the presence of liquid water. Later missions, such as Curiosity, found further evidence of ancient lakes and rivers, providing strong clues that Mars may have been habitable in the past. More recently, in 2018, scientists detected what appears to be a large subsurface lake of liquid water beneath Mars' southern polar ice cap. This discovery, made using radar data from the Mars Express orbiter, has sparked excitement, as underground water could provide a potential habitat for life. While the conditions in this subsurface lake are likely extreme, cold, salty, and high in pressure, it raises the possibility that microbial life could exist below the planet's surface. Additionally, Mars is home to large deposits of water ice just below the surface, particularly near the poles. NASA's Phoenix lander even uncovered water ice just centimeters below the surface in 2008. This ice could provide a future resource for human explorers or even serve as a habitat for life forms that can survive in extreme environments, similar to Earth's polar extremophiles. Mars rovers, uncovering the red planet's secrets. Over the past few decades, several robotic missions have explored Mars, providing unprecedented insights into the planet's geology, climate, and potential for life. NASA's Viking missions in the 1970s were the first to land on Mars and search for signs of life, though their experiments yielded no conclusive evidence. Since then, a fleet of orbiters, landers, and rovers have studied Mars in detail. NASA's Curiosity rover, which landed on Mars in 2012, has been exploring Gale Crater, an ancient lake bed, searching for conditions that might have been favorable for life. Curiosity has found evidence of organic molecules, carbon-based compounds that are essential for life, preserved in Martian rocks, adding to the growing body of evidence that Mars once had the right conditions to support life. In 2021, NASA's Perseverance rover arrived on Mars, carrying with it new tools to search for signs of ancient life. Perseverance is exploring Jezero Crater, a region that scientists believe was once home to a lake and river delta. This crater contains clays and minerals that could have trapped and preserved ancient microbial life. In addition to searching for biosignatures, Perseverance is collecting samples of Martian rock and soil, which will eventually be returned to Earth by future missions for detailed analysis, a critical step in determining whether Mars was ever home to life. Perseverance also carries the Ingenuity helicopter, the first aircraft to fly on another planet. Ingenuity's successful test flights have demonstrated the feasibility of aerial exploration on Mars, paving the way for future missions that might explore areas inaccessible to rovers. The search for life, present and past. The discovery of liquid water beneath Mars' surface, along with organic molecules and evidence of ancient lakes and rivers, has fueled speculation that life could still exist on Mars, even if only in microbial form. While the surface of Mars is harsh and exposed to radiation, the subsurface could offer a more stable environment where life could thrive. On Earth, extremophiles, organisms that survive in extreme environments, offer a model for how life might exist on Mars. Some microbes on Earth thrive in environments that are acidic, salty, or devoid of sunlight, such as deep-sea hydrothermal vents or the frozen lakes of Antarctica. These microbes have adapted to survive in conditions that were once thought to be uninhabitable, giving scientists hope that life could exist in similar niches on Mars. Additionally, methane has been detected in Mars' atmosphere in small, fluctuating amounts. Methane is a gas that, on Earth, is largely produced by biological processes, though it can also be generated by geological activity. The presence of methane on Mars raises the intriguing possibility that microbial life could be producing the gas, though further study is needed to determine whether the source is biological or geological. Future missions to Mars, such as ExoMars, a joint mission between the European Space Agency (ESA) and Russia's space agency Roscosmos, aim to drill deep beneath the Martian surface to search for signs of life. ExoMars rover Rosalind Franklin is equipped with a drill capable of reaching depths of 2 meters, where scientists believe life might still be preserved in the Martian soil. Mars and human exploration, preparing for the future. While the search for life on Mars is a major scientific goal, the red planet also holds a special place in our plans for human exploration. NASA's Artemis program, which aims to return humans to the moon by the mid-2020s, is seen as a stepping stone for sending astronauts to Mars. One of the biggest challenges for human missions to Mars is the planet's thin atmosphere and lack of easily accessible resources. However, scientists and engineers are developing technologies that could make long-term human exploration feasible. For example, NASA's Perseverance rover is testing a technology called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, which converts carbon dioxide from the Martian atmosphere into oxygen. This technology could one day allow astronauts to produce breathable air or even rocket fuel from Mars' natural resources, reducing the need to bring everything from Earth. Moreover, the discovery of water ice on Mars is seen as a potential resource for future explorers. Water could be used for drinking, growing food, and even producing fuel through electrolysis, where water is split into hydrogen and oxygen. The idea of sending humans to Mars, once confined to science fiction, is becoming increasingly realistic. Private companies like SpaceX, led by Elon Musk, have ambitious plans to establish a permanent human presence on Mars within the next few decades. While significant technological and logistical challenges remain, the dream of humans setting foot on the red planet is closer to becoming a reality than ever before. Is Mars the next frontier for life? Mars, with its intriguing geological history, evidence of ancient water and potential for life beneath its surface, continues to be one of the most promising targets in the search for extraterrestrial life. While we have yet to find definitive proof of life on Mars, each new discovery brings us one step closer to answering the question: has life ever existed on Mars, or could it still exist today? As missions continue to explore the red planet, both robotically and eventually with human explorers, Mars may hold the key to understanding not only the possibility of life beyond Earth but also the future of humanity's role as an interplanetary species. Chapter 7. The Fermi Paradox. Where is everybody? The universe is vast, so vast that it's nearly impossible to comprehend its scale. Our Milky Way galaxy alone contains billions of stars, many of which are orbited by planets that could, theoretically, support life. If the cosmos is teeming with stars and planets, many of them far older than our own solar system, then the question arises: where is everybody? This is the essence of the Fermi Paradox, one of the most puzzling questions in the search for extraterrestrial life. It was first posed in 1950 by physicist Enrico Fermi during a casual lunchtime conversation with colleagues. Given the size and age of the universe, Fermi wondered why, if intelligent civilizations exist, we haven't seen any definitive evidence of them. If there are other advanced civilizations, why haven't we detected their signals, encountered their spacecraft, or seen other signs of their existence? The Fermi Paradox highlights the disconnect between the high probability of extraterrestrial life and the lack of observable evidence. In this chapter, we'll explore possible explanations for the paradox and the implications it has for the search for life beyond Earth. The scale of the universe. Why we expect to find life. To understand the Fermi Paradox, we must first grasp the scale of the universe and the likelihood of life existing elsewhere. Our solar system is just one of an estimated 100 to 400 billion star systems in the Milky Way galaxy. Beyond that, the observable universe contains roughly 2 trillion galaxies, each with billions of stars. Given these numbers, the probability that Earth is the only planet capable of supporting life seems incredibly low. Moreover, the conditions for life, liquid water, a stable atmosphere, and essential chemicals, appear to be common throughout the universe. As we discussed in earlier chapters, exoplanets' inhabitable zones have been discovered in increasing numbers, suggesting that the ingredients for life may be widespread. If intelligent life has evolved on other planets and developed advanced technology, some civilizations should, theoretically, have had enough time to explore the galaxy or send signals across space. After all, our galaxy is over 13 billion years old, and some of its stars and planets are billions of years older than our solar system. With so much time and space, even a modestly advanced civilization should be detectable, either through direct contact or indirect signs like radio signals. Yet, despite the high probability, we have seen no clear evidence of such civilizations. This contradiction, between the high likelihood of extraterrestrial life and the lack of observable evidence, is what makes the Fermi Paradox so compelling. The Great Silence. Possible explanations for the Fermi Paradox. There are many possible explanations for the Fermi Paradox, ranging from the optimistic to the unsettling. Let's examine some of the most popular theories. 1. We're not looking in the right way. One of the simplest explanations is that we may not be using the right methods to search for extraterrestrial life. Much of our focus has been on detecting radio signals, as discussed in the previous chapter on SETI. However, it's possible that advanced civilizations don't use radio technology or have moved beyond it. They may communicate in ways we haven't discovered yet, such as through laser signals, quantum entanglement, or other methods that we lack the technology to detect. Additionally, our search has been limited to specific regions of the sky and to a narrow range of frequencies. The universe is so vast that it's possible we've simply missed the signals, or they may be too faint or brief for us to notice. We could also be looking in the wrong time frame. If civilizations are broadcasting signals at intervals of hundreds or thousands of years, we may have just missed their windows of communication. 2. Technological barriers. Another explanation is that civilizations may exist but are unable to reach us due to technological barriers. Interstellar travel is extremely challenging, even for an advanced species. The distances between stars are immense. Proxima Centauri, the closest star to Earth, is over 4 light-years away. Even with the fastest spacecraft we could currently build, it would take tens of thousands of years to reach it. Advanced civilizations might face similar limitations. Even if they have the ability to travel through space, the cost, time, and energy required might make widespread exploration impractical. Civilizations might be content to stay within their own star systems or immediate regions, without attempting to explore the galaxy at large. 3. The zoo hypothesis. One of the more speculative theories is the zoo hypothesis, which suggests that advanced civilizations are aware of us but have chosen not to make contact. According to this idea, extraterrestrials might view Earth as a kind of a zoo or nature reserve, where they observe us from afar without interfering, much like how we study wildlife in natural habitats without revealing our presence. The zoo hypothesis implies that extraterrestrials could be waiting for humanity to reach a certain level of technological or social development before revealing themselves. In this scenario, we are simply not yet advanced enough to warrant contact, or they may be following a strict non-interference policy, similar to the Prime Directive in Star Trek. 4. Civilizations self-destruct. One of the more somber explanations is the possibility that advanced civilizations tend to destroy themselves before they can spread across the galaxy. This theory, known as the Great Filter, suggests that there is a critical stage in a civilization's development, such as the discovery of nuclear weapons, climate change, or other forms of self-destruction, that prevents most intelligent species from surviving long enough to achieve interstellar travel or contact. If the Great Filter is real, it could mean that civilizations either never make it past the point of developing advanced technology or that those who do inevitably cause their own extinction. In this context, humanity may be approaching its own Great Filter. If we can overcome the existential challenges of our technological age, we might be able to survive long enough to explore the stars. If not, we could follow the same path to destruction that other civilizations might have taken. 5. We are truly alone. Perhaps the most unsettling explanation is that humanity is alone in the universe. Despite the vastness of the cosmos and the apparent abundance of habitable planets, it's possible that life on Earth is a rare or even unique event. Life may be far more difficult to originate than we currently understand, or the specific conditions that led to life on Earth might be exceedingly rare. If this is the case, the Fermi Paradox is not a paradox at all. There simply is no one else to find. While this idea is disheartening, it also places a unique responsibility on humanity. If we are the only intelligent life in the universe, our survival and exploration of the cosmos would take on even greater significance. The implications of the Fermi Paradox. The Fermi Paradox raises profound questions about humanity's place in the universe. If we are alone, it means that life on Earth is incredibly precious, and our future as a species becomes all the more important. It would suggest that we must safeguard our planet and ensure the survival of our civilization, as we may be the only intelligent beings capable of exploring and understanding the cosmos. On the other hand, if other civilizations exist but are silent or undetectable, it suggests that we still have much to learn about the universe. Perhaps we are on the verge of a great discovery, or perhaps we will eventually make contact when we have the technology and wisdom to understand it. The Fermi Paradox also serves as a reminder that, despite our technological advances, we are still at the beginning of our exploration of the universe. We've only scratched the surface of what lies beyond our solar system, and the search for extraterrestrial life is still in its infancy. As our capabilities improve, the chances of solving this paradox increase. What's next? To address the Fermi Paradox, scientists are pursuing a range of strategies. Continued investments in projects like SETI, along with new missions to explore the planets and moons in our own solar system, are crucial steps in the search for life. As telescopes become more powerful and capable of detecting biosignatures in the atmospheres of exoplanets, we may one day have the evidence we need to determine whether we are truly alone. Additionally, breakthroughs in fields such as artificial intelligence, machine learning, and quantum computing could help us analyze the massive amounts of data we collect from the universe, making it easier to detect subtle signals that may have gone unnoticed before. In the meantime, the Fermi Paradox serves as a thought-provoking mystery, encouraging us to look beyond our own world and consider the broader possibilities of life in the universe. Whether we find answers tomorrow or centuries from now, the search itself reflects our innate curiosity and desire to understand our place in the cosmos. Chapter 8: Extremophiles on Earth. Life in the unlikeliest places. As we continue our search for extraterrestrial life, one of the most important lessons comes from an unlikely source: Earth itself. While much of our planet is teeming with life, thriving in what we consider normal environments, there are places on Earth that are so extreme, so harsh, that they seem utterly inhospitable. Yet in these places life flourishes. Organisms that live in these hostile environments are known as extremophiles. Literally, lovers of extremes. They can survive and even thrive in conditions that would be deadly for most other life forms. The study of extremophiles has revolutionized our understanding of life's resilience and adaptability, expanding the range of environments where we might search for life on other planets. In this chapter, we'll explore the world of extremophiles, examine how they survive in Earth's harshest environments, and consider what they teach us about the potential for life in extreme environments elsewhere in the universe. What are extremophiles? Extremophiles are organisms that have evolved to survive in conditions that would be lethal for most life on Earth. These conditions include extreme temperatures, high levels of radiation, acidic or alkaline environments, and even high pressures found deep below the Earth's surface. Extremophiles belong to various domains of life, including bacteria, archaea, and even some forms of eukaryotes, organisms with complex cell structures like plants and animals. These remarkable organisms have developed specialized adaptations that allow them to tolerate or even exploit their extreme surroundings. For example, thermophiles thrive in high temperatures, while acidophiles live in highly acidic environments. By studying these organisms, scientists gain valuable insights into the limits of life and expand the range of environments we might consider habitable in our search for life beyond Earth. Types of extremophiles. There are several categories of extremophiles, each adapted to a specific type of extreme environment. Here are some of the most fascinating. 1. Thermophiles and hyperthermophiles, lovers of heat. Thermophiles thrive in extremely high temperatures, often found in environments like hydrothermal vents at the bottom of the ocean, hot springs, or volcanic areas. Hyperthermophiles, a subtype, can survive at temperatures exceeding 80 degrees Celsius (176 degrees Fahrenheit) and some can even thrive at temperatures above 120 degrees Celsius (248 degrees Fahrenheit), far hotter than the boiling point of water. The deep-sea hydrothermal vent bacterium Pyrolobus fumarii, for example, holds the record for living in temperatures as high as 113 degrees Celsius (235 degrees Fahrenheit). 2. Psychrophiles, thriving in the cold. On the opposite end of the temperature spectrum, psychrophiles are organisms that thrive in extremely cold environments. They can be found in polar ice caps, glaciers, and deep ocean waters. These organisms have evolved proteins and enzymes that remain functional at temperatures below freezing. The discovery of psychrophiles in subglacial lakes in Antarctica has shown that life can exist even in seemingly frozen, inhospitable environments. 3. Acidophiles and alkalophiles, surviving in extreme pH. Acidophiles thrive in highly acidic environments, where the pH can be as low as 1, such as in acid mine drainage or volcanic springs. One well-known acidophile is Acidithiobacillus ferrooxidans, a bacterium that thrives in the acidic waters of abandoned mines. On the other hand, alkalophiles prefer highly alkaline environments, such as soda lakes, where the pH can reach as high as 11. Both types of organisms have adapted their cellular structures and enzymes to maintain function in extreme pH conditions. 4. Halophiles, living in salt. Halophiles are organisms that thrive in environments with high concentrations of salt, such as salt flats, salt lakes, or even evaporating seawater. Some of the most well-known halophiles live in the Dead Sea and Utah's Great Salt Lake. These organisms have developed unique mechanisms to prevent dehydration and maintain cellular balance in environments that would otherwise cause most cells to shrivel and die. 5. Barophiles, thriving under pressure. Barophiles, also known as piezophiles, live under extreme pressure, often found in the deep ocean at depths where the pressure can exceed 1,000 times that of the surface. These organisms have evolved membranes and enzymes that function optimally under crushing pressures, such as those found in the Mariana Trench, the deepest part of Earth's oceans. 6. Radiophiles, tolerating high radiation. Radiophiles are organisms that can withstand high levels of radiation, far beyond what would be lethal to humans. One of the most famous radiophiles is the bacterium Deinococcus radiodurans, which can survive doses of radiation 1,000 times higher than those that would kill a human. Scientists believe this organism's ability to repair DNA damage is key to its resilience, offering intriguing possibilities for how life might survive on planets bombarded by cosmic radiation. Extremophiles and the search for extraterrestrial life. The study of extremophiles on Earth has expanded the range of environments we now consider possible habitats for extraterrestrial life. Before discovering extremophiles, scientists focused on searching for life in environments similar to Earth's temperate regions, where liquid water is present and conditions are stable. However, extremophiles have shown us that life can survive in much more extreme environments, and these revelations have reshaped how and where we look for life beyond Earth. Mars, potential for life below the surface. Mars, as we explored in the previous chapter, has a cold and arid surface, bombarded by radiation from space. However, extremophiles have demonstrated that life doesn't need to thrive on the surface. It can exist below. Microorganisms that survive deep beneath Earth's surface, where they are protected from harmful radiation and temperature extremes, offer a potential model for life on Mars. Given the presence of water ice below Mars' surface, combined with evidence of ancient rivers and lakes, it's possible that microbial life could be lurking beneath the Martian soil, just as extremophiles survive below Earth's surface. The discovery of liquid water beneath the ice at Mars' poles, along with fluctuating methane levels in its atmosphere, raises the possibility that Mars could harbor microbial life in its subsurface regions. Europa and Enceladus, oceans beneath ice. Two of the most promising candidates for extraterrestrial life in our solar system are the icy moons Europa, orbiting Jupiter, and Enceladus, orbiting Saturn. Both moons are believed to have vast oceans of liquid water beneath their icy surfaces, kept warm by tidal forces from their parent planets. The discovery of extremophiles in Earth's deep ocean hydrothermal vents has fueled speculation that similar life forms could exist in the subsurface oceans of these moons. On Earth, life thrives near hydrothermal vents despite the absence of sunlight, relying on chemical energy rather than photosynthesis. This has led scientists to consider that similar life forms could exist on Europa and Enceladus, where volcanic activity at the seafloor could provide the necessary energy for life. The plumes of water vapor observed erupting from Enceladus' south pole, and possibly from Europa as well, offer a tantalizing glimpse into the potential for life beneath their icy crusts. NASA's upcoming Europa Clipper mission, set to launch in the 2020s, aims to explore Europa's surface and plumes in greater detail, searching for biosignatures or other evidence of life. The possibility that extremophiles could exist in these alien oceans far from Earth is one of the most exciting prospects in the field of astrobiology. Titan, life in liquid methane. Another fascinating target in the search for life is Saturn's largest moon, Titan. Titan's surface is covered in lakes and rivers, not of water but of liquid methane and ethane. While methane-based life is purely speculative, the discovery of extremophiles on Earth that can survive in environments rich in hydrocarbons, such as oil reservoirs, has opened up new possibilities. On Titan, the conditions for life are radically different from Earth, with temperatures far below freezing. However, some scientists speculate that life could adapt to such an environment, using methane as a solvent instead of water. If such life exists, it would represent a truly alien form of biology, unlike anything found on Earth. NASA's Dragonfly mission, set to launch in 2027, will explore Titan's surface and atmosphere, seeking clues about its potential for hosting life. What extremophiles teach us about life's resilience? The discovery of extremophiles has radically changed our understanding of life's potential adaptability. These organisms demonstrate that life can persist in the most inhospitable places, challenging our assumptions about the limits of biology. Their existence has broadened the scope of our search for life beyond Earth, allowing us to consider environments previously deemed too hostile. Extremophiles have also highlighted the importance of looking beyond Earth's surface when searching for life. Just as life on Earth can survive deep underground or at the bottom of the ocean, it's possible that life on other planets or moons could be hiding beneath ice, rock, or even deep within atmospheres, shielded from extreme surface conditions. As we continue to explore our solar system and beyond, extremophiles offer a roadmap for understanding how life might arise and thrive in the most unexpected places. Their remarkable resilience reminds us that life, once it begins, finds a way to adapt, evolve, and survive, even in the harshest conditions. Conclusion: Extremophiles and the future of astrobiology. Extremophiles are living proof that life can survive and thrive in environments far beyond what we once thought possible. Their existence on Earth suggests that life could exist elsewhere in the universe, even in places with extreme temperatures, high radiation, or crushing pressures. By studying extremophiles, scientists are expanding the range of environments they consider habitable, both within our solar system and on exoplanets light years away. As missions to Mars, Europa, Enceladus, and Titan progress, we may one day discover life forms that have adapted to environments previously deemed too extreme. Extremophiles have taught us that the limits of life are far more flexible than we once believed, and the search for extraterrestrial life is just beginning. Chapter 9: The Ethics and Consequences of First Contact. The moment we make contact with extraterrestrial life, whether it's through a distant radio signal or a direct encounter, will likely be the most transformative event in human history. Such a discovery would answer one of the deepest and oldest questions humanity has ever asked. Are we alone in the universe? But with this revelation comes a host of ethical dilemmas and profound consequences, both for humanity and for the extraterrestrial beings we might encounter. What would happen if we found ourselves face to face with intelligent beings from another world? How would we communicate, and what would be the political, cultural, and social ramifications of such an encounter? The questions surrounding the ethics of first contact are as vast as the universe itself, and the answers remain elusive. The nature of first contact. What are we preparing for? First contact could take many forms, and the nature of the encounter would dramatically shape its ethical and societal impact. Would we receive a signal from a distant, advanced civilization, one so far away that direct interaction would be impossible? Or would we discover microbial life on a nearby planet like Mars or Europa, igniting debates about contamination and planetary protection? Perhaps the most dramatic scenario would be an encounter with an alien spacecraft or intelligent beings visiting Earth. Each of these possibilities carries its own set of ethical challenges. The discovery of microbial life might be primarily a scientific and philosophical issue, while direct contact with intelligent extraterrestrials could shake the very foundations of our global society. Regardless of how contact occurs, the implications are profound. We would need to consider not only how we respond but also how the extraterrestrials might perceive us. Would they see humanity as a potential ally, a curiosity, or a threat? Would they be benevolent, indifferent, or hostile? These are questions that have long been explored in science fiction, but real-world answers remain speculative at best. The ethical dilemma: how should we approach extraterrestrial life? If we were to encounter intelligent extraterrestrial life, one of the first ethical questions would be, how do we engage with them? Do we have the right to initiate contact? The ethics of such interactions are complex and depend on how we define the rights of extraterrestrial beings. Do we treat them as equals with their own inherent rights, or do we approach them as potential resources, much like explorers of the past treated new lands and peoples? This dilemma has deep historical roots in humanity's own colonial past. When European explorers encountered indigenous populations in the Americas, Africa, and other regions, the resulting interactions were often violent, exploitative, and devastating for the indigenous peoples. Many ethicists argue that we must learn from these mistakes and approach any potential contact with extraterrestrials with caution, humility, and respect. One concern is the possibility of cultural contamination. Just as indigenous cultures were often irrevocably changed by contact with technologically superior colonizers, so too might an alien civilization be impacted by humanity's knowledge, technology, or beliefs. If we are the more advanced species in the encounter, we must consider the consequences of introducing our ways of life to another civilization. Could we unintentionally harm them? Would we impose our own values or systems on them, much as humans have done to each other throughout history? Conversely, if we were to encounter a more advanced civilization, how would we protect our own cultural identity? Would humanity remain intact in the face of potentially overwhelming alien technologies and ideologies? The idea of cultural preservation, both for us and for any extraterrestrials we meet, is central to the ethics of first contact. Planetary protection, preserving both worlds. The search for life has so far focused on planets and moons within our solar system, especially Mars, Europa, and Enceladus. But what if we discover microbial life on one of these worlds? How do we ensure that we don't contaminate these ecosystems with Earth-based organisms? Planetary protection is a critical ethical issue in astrobiology. Space agencies like NASA and ESA follow strict guidelines to prevent contamination when sending spacecraft to other planets. These guidelines ensure that we do not introduce Earth life to other worlds, which could potentially destroy or alter native ecosystems before we even know they exist. But planetary protection works both ways. If we bring back samples from Mars or another celestial body, how do we ensure that we don't inadvertently introduce alien microbes to Earth? Such a scenario could pose unknown risks to our biosphere, and the consequences of contamination could range from benign to catastrophic. Protecting both Earth and any extraterrestrial life forms we encounter requires careful, deliberate action, and possibly difficult decisions about whether or not we should even attempt direct contact with alien life. The impact on society, global reactions to first contact. The discovery of extraterrestrial life would trigger a global response unlike any event in human history. If we received a message from an advanced civilization, or even confirmed the existence of simple microbial life on another planet, the cultural, religious, and political ramifications would be profound. Culturally, humans have long viewed ourselves as the center of the universe. The Copernican revolution in the 16th century shattered the notion that Earth was the center of the cosmos, but many of our cultural narratives still assume that humanity is unique. the discovery of alien life would challenge this deeply ingrained belief. Religions around the world would need to reinterpret their teachings in light of the new understanding that we are not alone. How would different belief systems accommodate the idea of intelligent beings from other worlds? Would such a discovery unite us as a species, or further divide us? Politically, the discovery of extraterrestrial life would likely provoke a range of reactions. Governments would need to decide how to handle such knowledge, particularly if contact was made with an intelligent civilization. Would nations work together to respond, or would they compete for resources, knowledge, and potential alliances with extraterrestrials? History suggests that competition rather than cooperation might dominate the initial response. The consequences of a fragmented or confrontational approach to first contact could be disastrous, both for humanity and for any extraterrestrials involved. There is also the issue of public reaction. The prospect of contact with extraterrestrials has long fascinated the public, but the reality of such an event might provoke fear, panic, or even violence. How governments and institutions communicate with the public about the discovery of extraterrestrial life will be crucial in shaping the global response. Transparency, education, and a commitment to peaceful engagement will be essential to avoid mass hysteria or misunderstandings. The consequences of first contact. A new era for humanity. If we do make contact with extraterrestrial intelligence, the consequences for humanity will extend far beyond the immediate response. Such a discovery could fundamentally change how we view ourselves and our place in the universe. We would no longer be the only known intelligent species, and that realization could trigger profound changes in our collective worldview. Philosophically, the discovery of extraterrestrial life could lead to a rethinking of humanity's purpose. Are we just one of many intelligent species, destined to play a small role in a much larger cosmic drama? Or does our uniqueness as intelligent beings on Earth give us a special responsibility, to each other, to our planet, and to any life forms we encounter? On a practical level, contact with an advanced civilization could accelerate human technological development. We might gain access to knowledge and technology far beyond our current capabilities, revolutionizing everything from medicine to space travel. However, this raises ethical concerns about the potential for misuse. Would these advances be shared equally, or would they exacerbate existing inequalities and conflicts on Earth? Could such technologies be weaponized, leading to new forms of warfare or domination? Ultimately, the consequences of first contact, whether with microbial life or intelligent civilizations, will depend on how we choose to respond. Will we approach the unknown with curiosity, respect, and cooperation? Or will fear, greed, and division define our interactions with extraterrestrial life? Preparing for first contact, looking to the future. As we continue to explore space and search for life beyond Earth, it's essential that we prepare for the possibility of first contact. This preparation involves not only developing the technology to detect and communicate with extraterrestrial civilizations but also addressing the ethical, cultural, and political challenges that will arise. International cooperation will be key. Just as climate change and other global challenges require collaboration, so too will the discovery of extraterrestrial life. The United Nations, space agencies, and international organizations will need to establish frameworks for how humanity engages with alien civilizations, ensuring that the interests of all people, and potentially the extraterrestrials themselves, are respected. At the same time, we must remain cautious. While the discovery of life beyond Earth would be an extraordinary scientific achievement, it could also bring unforeseen risks. Protecting Earth's biosphere, preserving cultural identities, and preventing conflict will be critical as we navigate this new frontier. As we look to the stars, the possibility of first contact reminds us that we are part of a vast and mysterious universe. Whether or not we are alone, the search for life beyond Earth has already begun to reshape how we see ourselves. And when the day comes that we meet another intelligent species, it will mark the beginning of a new chapter in the story of humanity. Chapter 10, The Future of Our Search. What's next? As humanity continues to push the boundaries of exploration, the search for extraterrestrial life is poised to enter an exciting new phase. Advances in technology, along with a deeper understanding of where and how life might exist beyond Earth, are driving the next wave of scientific missions and innovations. Whether it's through interstellar travel, advanced telescopes, or new exploration missions within our own solar system, the question of whether we are alone in the universe is closer than ever to being answered. In this final chapter, we'll explore what the future holds for the search for extraterrestrial life, from cutting-edge technology to upcoming missions. We'll look at how humanity's growing knowledge and capabilities are positioning us to make one of the most profound discoveries in history: the detection of life beyond our planet. Next-generation telescopes, a clearer view of distant worlds. One of the most critical tools in the search for extraterrestrial life is the telescope, and in the coming years, we are set to witness a revolution in our ability to observe distant stars and planets. Telescopes such as the James Webb Space Telescope (JWST), launched in 2021, and other upcoming observatories like LUVOIR, Large Ultraviolet Optical Infrared Surveyor, and HABEX, Habitable Exoplanet Observatory, promise to transform our understanding of the universe. The JWST, for example, is designed to look deeper into space and further back in time than any previous telescope. It has the capability to study the atmospheres of exoplanets, searching for key biosignatures, gases like oxygen, methane, and carbon dioxide, that could indicate the presence of life. The ability to analyze the chemical composition of distant worlds is a game-changer in astrobiology, offering a direct method of detecting the conditions necessary for life. These next-generation telescopes will not only focus on distant exoplanets but also on our own solar system, where they will study the moons of Jupiter and Saturn, particularly Europa and Enceladus, for signs of life. Their advanced capabilities will help scientists answer the most pressing questions about these icy moons, including whether liquid oceans beneath their surfaces could support life. Additionally, telescopes like the Square Kilometre Array, SKA, an enormous radio telescope project being developed in Australia and South Africa, will dramatically increase the sensitivity of our search for extraterrestrial signals. With the SKA, SETI researchers will be able to scan vast portions of the sky for faint, distant signals that might otherwise go undetected. Together, these instruments represent humanity's most ambitious effort yet to detect alien life. Robotic explorers, reaching out to our neighbors. While telescopes allow us to look deep into space, robotic explorers will be critical for probing the worlds in our own solar system where life might exist. Mars, Europa, and Enceladus remain key targets, and upcoming missions will push our understanding of these planets and moons to new heights. On Mars, NASA's Perseverance rover is already on the surface, searching for signs of ancient life and collecting samples that will eventually be returned to Earth. This Mars sample return mission, slated for the late 2020s, could provide definitive answers about whether microbial life ever existed on the red planet. Scientists will analyze these samples with sophisticated equipment on Earth, potentially uncovering evidence of past or present life. Meanwhile, Europa, Jupiter's icy moon, will be explored in detail by NASA's Europa Clipper mission, scheduled for launch in the mid-2020s. The spacecraft will make multiple flybys of Europa, mapping its surface, studying its ice shell, and searching for clues about the liquid ocean believed to lie beneath. If life exists on Europa, it may be in the form of microbes living in the deep ocean, potentially near hydrothermal vents, similar to those found in Earth's oceans. Enceladus, Saturn's moon, is another promising candidate. With its plumes of water vapor and organic compounds erupting from its surface, Enceladus offers a rare opportunity to study material from a subsurface ocean without having to drill through ice. Future missions to Enceladus, like Enceladus Life Finder, proposed, or other exploratory spacecraft, could further investigate these plumes, searching for signs of life hidden in the moon's subsurface waters. Robotic missions, whether orbiters, landers, or rovers, provide us with unprecedented access to these alien worlds. As technology continues to improve, these missions will become more capable of carrying out complex tasks, such as drilling deeper into ice or soil, or even bringing samples back to Earth. Robotic exploration will remain at the forefront of the search for life in our solar system for years to come. Interstellar exploration, beyond the solar system. While the search for life within our solar system is well underway, the dream of exploring beyond it is still in its infancy. Interstellar travel, reaching stars beyond our own, remains a formidable challenge. The vast distances between stars, combined with the limitations of our current propulsion technologies, make it unlikely that we will send human explorers to another star system anytime soon. However, innovative projects are in development that aim to break through these barriers. One such initiative is Breakthrough Starshot, an ambitious project funded by Russian billionaire Yuri Milner. The goal of Breakthrough Starshot is to send a fleet of tiny lightweight probes, powered by laser-driven sails, to Proxima Centauri, the closest star system to Earth, located about 4.2 light-years away. These probes, traveling at up to 20% of the speed of light, could reach Proxima Centauri in about 20 years, sending back images and data about its planets, including the potentially habitable exoplanet Proxima Centauri b. While Breakthrough Starshot represents a technological leap, it is just the beginning of humanity's efforts to explore beyond our solar system. Future advancements in propulsion technology, such as nuclear fusion or antimatter drives, may one day make interstellar travel a reality. As our knowledge of exoplanets grows, so too will our desire to explore them firsthand, whether through robotic missions or, eventually, crewed spacecraft. Artificial intelligence and machine learning, unlocking the universe's secrets. Another key factor in the future of the search for extraterrestrial life is the role of artificial intelligence, AI, and machine learning. The sheer volume of data collected by telescopes, satellites, and space missions is staggering, and analyzing this data manually would be impossible. AI and machine learning are being used to sift through this vast amount of information, identifying patterns, signals, and anomalies that human observers might miss. In SETI, for example, machine learning algorithms are being developed to detect subtle signals in radio and optical data, filtering out the noise of space to find potential signs of extraterrestrial technology. AI is also being used to process the data from missions like Kepler and TESS, helping scientists identify promising exoplanets in the habitable zones of their stars. As AI continues to advance, it will play an increasingly important role in our search for life beyond Earth. Whether it's automating data analysis, guiding robotic explorers, or even helping design the next generation of space missions, AI will be an indispensable tool in unlocking the secrets of the universe. The role of private industry, expanding humanity's reach. The rise of private space exploration companies like SpaceX, Blue Origin, and Rocket Lab is another game-changer for the search for extraterrestrial life. These companies are pushing the boundaries of what is possible in space travel, from reusable rockets to ambitious plans for crewed missions to Mars. SpaceX, led by Elon Musk, has set its sights on colonizing Mars, with plans to send humans to the Red Planet within the next decade. Musk's vision for a self-sustaining human colony on Mars represents a bold step forward in humanity's exploration of space. While the primary goal is to ensure the survival of humanity, the colonization of Mars would also advance the search for life. With humans on Mars, we could explore the planet more thoroughly and rapidly than ever before, potentially discovering signs of life beneath its surface. Private industry is also playing a role in the development of new space technologies, from more efficient propulsion systems to advanced habitats for long-duration space travel. As these companies continue to innovate, they are likely to accelerate humanity's progress in exploring the solar system and beyond. The philosophical questions: what if we find life? While technology and missions are essential to the search for life, the discovery of extraterrestrial life, whether microbial or intelligent, raises profound philosophical questions. How would the discovery of life beyond Earth change our understanding of our place in the universe? Would it unite humanity or further divide us? If we find microbial life on Mars or Europa, it would confirm that life is not unique to Earth. Such a discovery would suggest that life could be common throughout the universe, emerging wherever the conditions are right. This would challenge long-held assumptions about the rarity of life and force us to rethink our understanding of biology, evolution, and the potential for life in extreme environments. The discovery of intelligent extraterrestrial civilizations would have an even greater impact. It would raise ethical questions about how we engage with other intelligent species, and what responsibilities we have to them, and to ourselves? Would we be able to coexist peacefully, or would fear and mistrust dominate the interaction? How would our religious, cultural, and political institutions respond to the knowledge that we are not alone? The search for extraterrestrial life is not just a scientific endeavor, it is a quest that touches on the deepest questions of human existence. As we move forward, it is essential that we consider the broader implications of what we might find, and prepare ourselves for the possibility that we are not the only intelligent beings in the universe. Conclusion: the next frontier. The future of the search for extraterrestrial life is bright, filled with technological innovation, scientific discovery, and the promise of uncovering one of the greatest mysteries of all time. As we build more powerful telescopes, send robotic explorers to distant worlds, and develop the capability for interstellar travel, we are pushing ever closer to the moment when we might finally answer the question, are we alone? The search will take us to the farthest reaches of the cosmos and the most extreme environments in our own solar system. It will challenge our understanding of life and force us to confront new ethical and philosophical questions. But as we continue this journey, one thing is certain: our quest to find life beyond Earth is not just about solving a mystery, it's about understanding our place in the vast, interconnected universe. The next frontier in the search for extraterrestrial life awaits us. Whether the discovery happens tomorrow or centuries from now, we will continue to reach out, driven by the hope that somewhere out there life is waiting to be found. Conclusion: fact, fiction, or somewhere in between. The search for extraterrestrial life has taken us from ancient myths and legends to the cutting edge of modern science. It is a journey that spans thousands of years, from early speculation about life on other worlds to the sophisticated space missions and telescopes of today. Yet, despite all our technological advancements and scientific progress, the answer to the question, are we alone in the universe, remains elusive. The possibility of life beyond Earth is a tantalizing mixture of fact and fiction. The discovery of extremophiles on Earth, the detection of thousands of exoplanets in habitable zones, and the growing evidence of water beneath the surfaces of Mars, Europa, and Enceladus all point to the real possibility that life could exist elsewhere. These facts provide a scientific foundation for the search, reinforcing our belief that we might one day find microbial or even intelligent life beyond our planet. At the same time, fiction has played a critical role in shaping how we imagine extraterrestrial life. From H.G. Wells' The War of the Worlds to the blockbuster films and TV shows of today, fiction has explored every conceivable scenario of first contact, alien invasion, and peaceful coexistence. These stories capture our imagination, giving life to the possibilities that science is still working to prove or disprove. But what if the truth lies somewhere in between? The scientific reality, moving closer to an answer. In many ways, we are closer than ever to answering the question of whether life exists beyond Earth. The rapid pace of discovery in astrobiology, the continuous stream of exoplanet findings, and the development of next-generation telescopes mean that we are gathering more data than ever before. Each new mission, whether it's to Mars, Europa, or distant exoplanets, brings us one step closer to solving the mystery. Yet, we must also acknowledge the immense challenges that remain. The vastness of space, the limitations of our current technology, and the unknown variables in how life might evolve on other planets all make the search difficult and uncertain. We may detect a promising signal or find evidence of past life on Mars, but definitive proof of extraterrestrial life could still be years, decades, or even centuries away. As we move forward, it's important to maintain both our scientific rigor and our sense of wonder. The search for extraterrestrial life is not just about finding microbes or hearing alien radio signals, it's about exploring the limits of what we know and expanding our understanding of the universe. The ethical and philosophical questions. What if we're not alone? Beyond the scientific quest, the discovery of extraterrestrial life, whether microbial or intelligent, would have profound ethical and philosophical implications. How we choose to engage with life on other worlds will reflect our values as a species. Will we approach it with humility and respect, or will we repeat the mistakes of our colonial past, viewing extraterrestrial life as something to be exploited or dominated? If we are not alone in the universe, we must ask ourselves what that means for humanity's sense of identity and purpose. How will our religions, cultures, and societies adapt to the knowledge that we are part of a much larger cosmic community? Will such a discovery bring us together, or will it divide us further as we grapple with the implications of sharing the universe with other intelligent beings? These are not easy questions, but they are ones we must begin to consider as we stand on the threshold of one of the greatest discoveries in history. The possibility of silence. What if we are alone? While the possibility of discovering life beyond Earth excites our imagination, we must also confront the possibility that we may be alone. Despite the billions of stars and planets in the universe, it is possible that Earth is the only place where life has taken hold. If this is the case, it would make life on Earth even more precious. The fragility and uniqueness of life on our planet would take on new significance, and humanity would bear an even greater responsibility to protect and preserve the biosphere. The realization that we are alone in the universe would be both humbling and awe-inspiring, forcing us to reflect on the rarity of our existence and the importance of sustaining life on our planet. Hope for the future. The search continues. Despite the uncertainties and challenges, the search for extraterrestrial life is a journey of hope. It reflects our deepest desire to understand the universe and our place within it. Every discovery, whether it's a new exoplanet in the habitable zone or a microbial fossil on Mars, adds to the growing body of evidence that life may exist beyond Earth. The search is far from over. With each new generation of scientists, explorers, and visionaries, humanity moves closer to finding the answer. Whether we discover life in our solar system, detect a distant signal from a far-off star, or build the technology to travel to other worlds, the quest will continue. In the end, the search for extraterrestrial life is not just about solving a scientific mystery, it's about understanding what it means to be human in an infinite universe. Are we the only intelligent beings in the cosmos, or are we part of a larger galactic community, waiting to be discovered? The answers may still lie beyond our reach, but the pursuit of knowledge and the desire to explore will always drive us forward. Fact, fiction, or somewhere in between? As we conclude this exploration, we are left with a sense of wonder. The search for extraterrestrial life, whether it leads to a distant signal or a hidden microbe beneath the ice of a distant moon, is one of the greatest scientific endeavors of our time. It is a journey that blends fact and fiction, science and imagination, caution and hope. While we may not have all the answers yet, we stand at the edge of discovery. The search for extraterrestrial life is far from over, it is just beginning. And as we continue to explore the stars, we carry with us the hope that somewhere out there life is waiting to be found.